Welcome to ClickMyProject.com. Let me discuss about the abstract of the project. Energy efficiency and spectral efficiency are plays an important role in wireless communication systems. The increase in demand for frequency bands with high data rate requirements, we are in need to efficiently utilize the available spectrum with better energy efficiency. So cognitive radio networks are plays vital role in utilizing the available unused spectrum efficiently with better energy efficiency. Existing work investigated power allocation schemes for a single CR user based MIMO OFDM systems. In this project, the system MIMO OFDMA, which is a promising candidate for 3GPP LTE, is proposed. The sum capacity of a multi-user synchronous CDMA system is completely characterized. In the general case of asymmetric user power constraints, the sum capacity computation relies on a duality between the Gaussian vector broadcast channel and the sum power constraint Gaussian multiple access channel. The numerical algorithm is based on the Lagrangian dual decomposition technique, and it uses a modified iterative water filling approach. For the Gaussian multiple access channel, the algorithm converges to the sum capacity globally and efficiently. Let me discuss about the flow diagram for our process. Initially, the parameters has been initialized. Next, generate the channel matrix based on the base station, primary user and the secondary user. This is the system model. A one-cell wireless system where the PU and the SU transceiver coexist in the same geographical location is assumed. The scenario is investigated for a downlink path and KCR users. Primary users base station transmit signals to PU primary users, each of which occupies a determined frequency band in the available spectrum. The CR network has an individual base station that identifies the spectrum holes on the basis of the collected information about the spectrum, then deactivates primary user subcarrier and transmits its users information on the remaining subcarriers. Next, the subcarrier allocation. In a single channel communication system, the de-amplification and loss present on them can be simplistically taken as attenuation by the percentage. Then amplifiers restore the signal power level to the same value at a transmission setup by operating at a gain. If we experienced 6 dB attenuation in transmission, 70% loss will be occur. Then we have to amplify the signal by a factor of 4 cross to restore the signal to the transmission level. The search for a proper subcarrier allocation for CR network is inspired by the optimal user selection for subcarrier. Next, the power has been allocated. By allocating a specific user for any subcarrier in conformity with the proposed metric, the optimization problem becomes similar to one optimization problem for a single CR user case. Finally, the capacity maximization. With regard to the results and assumption proposed in previous section, the problem of maximizing the capacity in the downlink path can be formulated. If the interference will be less than threshold, then maximize the capacity of assigned user. Finally, we analyze the performance graph based on the capacity maximization with the help of water filling algorithm. In order to compare the performance of newly proposed algorithm with the previous ones fairly after determining the proper power for each branch by the Lagrangian based algorithm in each iteration. Let me discuss about the running procedure for our process. Select the main.m file in the current folder, rail the file and run for executing this process. Here, capacity of full channel state information for every subcarrier has been calculated. After completion of capacity estimation, we will obtain the capacity graph for our all subcarriers. This process will take some time for executing. After performing the capacity estimation, we obtain the performance graph. This is the capacity by varying the iteration number, and the capacity of bits per seconds will be reduced. And this is the total capacity of cognitive radio network. Here Lagrange algorithm and also CMA algorithm are used for our 8 cognitive radio users and 16 cognitive radio users. And this is the total capacity of cognitive radio users for constant modulus algorithm, Lagrange resource algorithm, suboptimal resource algorithm. Compare the results with our existing system. And this is the total capacity of CR users. This is 2x2 system, and this one is 4x4 system. Here 2 transmitter and 2 receivers are placed. This graph compare with the existing system. Finally, we analyze the capacity maximization algorithm. Thank you.